Let's take the following application. Observe the reaction represented in the following equation. The reaction between iron and sulfur under the effect of heat leads to the formation of iron 2 sulfide FeS. Given that the mass is equal 4.16 for sulfur and 11.2 grams for Fe. Part 1 show that the initial mixture of reactants is not stoichiometric. To prove that the reactant mixture is not a stoichiometric, we have to calculate the ratio of sulfur and the ratio of iron. But before calculating ratios, you have to calculate the number of mole of sulfur and that of Fe. Number of mole of sulfur equal mass over molar mass, which is equal 0.13, and that for Fe equal 0.2. As a result, both ratios are different, which means that the reactant mixture is not stoichiometric. In part 2, identify the limiting and the excess reactant. Since the ratio of sulfur is lower than the ratio of iron, this means that sulfur is the limiting reactant and iron is an excess. Limiting reactant is the reactant that is totally reacted at the end of the reaction, while a part from the excess reactant remained at the end of the reaction. Calculate the mass of iron 2 sulfide FeS formed. To calculate it according to the given rule, equal number of mole times molar mass. Molar mass, it's equal to the sum of the two molar masses, which is equal 88. Number of mole is calculated by using a stoichiometric ratio. To calculate number of mole FeS, you have to take it with the limiting reactant, which is sulfur. Don't forget this. So number of mole of FeS equals 0.13, and finally the mass of FeS formed equal 11.44 gram. This mass is called the theoretical mass, the theoretical quantity, since it's calculated by using stoichiometric calculations. In part 4, it's required to calculate the percentage yield of this reaction, knowing that the obtained mass of FeS is 9.5 gram. This 9.5 gram is the experimental mass, it's the experimental quantity. So the experimental quantity 9.5 gram is the quantity obtained in the laboratory, while the theoretical quantity is the quantity obtained by the calculation using the stoichiometric calculations. So as a result, the percentage yield, it's the experimental mass over theoretical mass times 100. So the final answer is 83.04.